Hello viewers, welcome back to our YouTube channel, and today we want to look at the pie chart. We want to look at the pie chart. Of course, we are continuing with our series of quantitative techniques, and we are basically trying to go through the different data presentation techniques, and specifically we are on the verge of completing our charts. And as we promised that we shall look at the pie charts. So let's try to understand what pie charts are all about. So a pie charts, of course, pie charts are a way of representing data so that it can be understood and interpreted. So a pie chart totally shows, of course, this shows, pie chart shows the totality shows the totality of the data, shows the totality of the data, shows the totality of the data being represented, shows the totality of data being represented using, shows the data being represented using sectors or portions of a circle. That's what we call a pie chart. So the circle is going to be split into different sections, each one of the sections being drawn in proportion to the data that it represents. So we draw them basing on the data that they are representing. Of course, we understand that as you are looking at the pie charts, we know that the whole circle is 360 degrees. So each of these sectors of the pie chart will represent a fraction of the whole total. That's why we are saying it is the totality. In other words, each portion or fraction of the 360 is going to be represented by each sector. So the pie chart, as we said, it is one of the tools that are extensively used in statistics, and the purpose for the pie chart or the pie graph is to show the relationship. It shows the relationship of the parts of the whole. In other words, you look at the relationship of the parts to the whole by visually comparing the sizes of the sections. So the percentages or the fractions can be used to be able to compare the different sizes of each of the different sections. So the variable that we might be dealing with in this perspective could be a nominal, or it could be a categorical variable. So a pie graph is just, of course, as we said, that it is just a circle that is divided into sections or what we call wedges. You don't call it sections, of course you can call them wedges. W-E-D-G-E-S, wedges. Wedges, like that. So these portions, of course, they are the ones that are forming, up, or they are the ones that we look at and we see the composition of each of the sections, and these sections, they are according to the percentage of the frequencies in each of the category of distribution. So we have a formula. For getting what we call those angles that we are going to use for the formula. The formula is actually, of course, this formula is helping us to determine the angle of each sector. So we get the angle of a sector or a portion. So angle of a sector, of course, we get it by getting the frequency of the data over the total frequency times 360, which is the total degrees that are available in a whole circle. So here we get it is equivalent to getting the frequency of data over the total frequency times 360 degrees. Of course, we've said that these we are looking for angles. So we know that a circle is going to have 360 degrees. So before we pick up maybe a small illustration to try and test what we have talked about, we have maybe to at least give small steps, the steps to constructing a pie chart. We have the steps for construction of a pie chart. Steps to construct a pie chart. Of course, the first one is for us to calculate. The first one is to calculate the angle of each sector using the formula that we have identified above. So first calculate the angle of each sector using the above formula. Then the second step is, of course, for us to draw a circle using a pair of compasses. Using a pair of compasses. Then the third step is for us to use a protractor. Use a protractor to draw the angles. To draw the angle of each sector. And of course, finally, is for us to label the circle, or to label our pie chart and all its sectors. Label the circle, label the circle, the circle graph, label the circle graph, and label the circle graph and all its sectors. So let's look at maybe an example. Let's look at an example and we see what we can do. Example, let's say that in an institute, there are 750 students. 750 students in level 1. Of course, these are CPA students. Then 420 students. 420 students in level 2, and the 630 students in level 3. And of course, the required is to draw a pie chart to represent the students in each level. The required is for us to draw a pie chart to represent students in each level. Let's start with the solution. Of course, in such a scenario, we will say that the first step is for us to compute the angle for each of the sections using the formula that we already looked at, which is the frequency of the data of a given sector divided by the total frequency for all the sectors times 360 degrees. So we said that we get the formula is for us to get the angle when we want to look at the angle of a sector, and we said it is equivalent to the frequency over the total frequency times 360 degrees. Now we need to get the total frequency, and of course, in terms of the frequency here, we have the number of students. So we want to get now the total number of students. Total number of students. The total number of students, we have seen that level 1 has 750 plus those in level 2, which are 420, then plus those in level 3, which were 630 plus 630. So you will see that these are actually equivalent to 1800. So this is equivalent to 1800. That is the total number of students that we have in that institute. Now we want to look at the size of the angle for level 1, size of the angle for level 2, size of the angle for level 3. So we are going to take up the level 1. Level 1, we look at the size of angle, which is equivalent to the level 1 number of students over the total number of students. Number of students in level 1 over the total number of students in the entire institute times 360 degrees. So it is going to give us 750 divided by 1800 times the 360 degrees. So the answer we get is in degrees. This is 150 degrees. Then we look at level 2. Level 2, still we are looking for the same. We are still looking for the size of the angle for level 2. And of course, the number of students who were in level 2 were 420 divided by the entire total in the school of 1800 times the 360 degrees, and this will give you 84 degrees. And of course, we compute the last one for level 3. The total number of students in level 3 were 630 divided by the total number of students in the institute of 180 of 1800, then times the 360 degrees. So let's look at the level 3. We are still looking for the angle. We say there are 630 students in level 3. So it is 630 divided by 1800 times the 360 degrees. That gives you 126 degrees. So once you add the degrees for all these 3 levels, they must give you 360 degrees. Of course, once we have gotten that, then we go ahead to draw the circle. Drawing the circle, you draw, of course, you draw a circle. So we can use, of course, when you use a pair of compass, you will have a very clear circle. But we've seen that the level 1 students were actually representing 150 degrees. So it means it is the largest. So since we are, of course, we know that if we are to just get this, that will be the radius. So if we complete it to become a diameter, then we shall have 180. But since this is 150, we can take it maybe to be at that point. We say that this is 150 degrees. We draw the table, we draw the circle. We then measure the angles of each sector. Now, of course, the next one is 80, 87. It is 84. So we start from where we put our protractor here, where we have ended this first one. Then we measure moving this side in a clockwise direction. So we can maybe start by plotting off the other bigger one of level 3, which is 126. So when we plot off the 126, whatever the balance, since we only have 3 units, the balance will actually represent the level 2 because it is the smallest. So this one, we can take it maybe in this way, and maybe we say this one. It is not going to be bigger than the other one. So this is 126. 126. But of course, since we are moving clockwise, let's put it in this way. This is 126 degrees. Of course, this balance will now be the 84 degrees. Then we need to shade. So this one we can shade it maybe like this, using those. We shade and then we give a scale. Maybe this one we can use X. Then the other one we can leave it unshaded. So we come here and represent our key. Of course, we have the one that is represented by V. This is level 1. Then the one that is not shaded, that is level 2. Then the one that is represented by X will be the level 3. And that will be done. But of course, one key thing that you always have to indicate is of course the title, because we said these charts always have a title. So you can put maybe number of students per level, a pie chart showing the number of students per level. That can be our title, because these sections, the different sections that we have got, represent the information to do with the number of students in different levels, from level 3, level 1 to level 3. So here we can say, you can just say maybe number of students, you can just say number of students per level, students per level. That can be our title, because it's well understood that even if you don't indicate, of course it's always good to indicate that a pie chart showing, but if you have drawn a circle, of course it will be showing even if you don't write that it's a pie chart. it will be seen as a pie chart, but you have to always put an appropriate title to the diagram that you have drawn. Of course, we have some advantages. We find that it is very easy to interpret the data that is presented in pie charts. It is easy to interpret. Then, of course, it's also good for comparing data. I told you one of the reasons why we use the pie charts is for us to be able to get the relationship or the comparison of data in relative terms. You look at data of a section and that of the other section. So you can compare that there are very many students in level 1 because it is represented by the largest portion on the pie chart or on the circle. Then of course it is also easy for you to compute, to show the percentages of the total for each category. Of course, if you have to convert this into a percentage, just multiply by 100. Some of the disadvantages, of course, we have some computations. Just imagine if we had information of about maybe 20 students or 20 categories or 20 levels. It would be very tedious for us to compute the information, and at some point it may involve things to do with decimal points. You know, on the protractor we don't have decimal values, so we will be able to round off all these values to their nearest whole numbers so that we can be able to plot the appropriate figures. So all that is going to be some tedious mathematical computations are involved. Then of course the other is we can have untidy work, because just imagine if we are using one circle to represent 30 items, they will all go there, but we are going to have work that is going to be not a neat work, because even after presenting these sections, we need to shade them, and we have to shade them differently to be able to create a difference between the different sections. So if we have very many sections, first of all, they are going to be crowded, they are going to be overcrowded, and then we end up having untidy work. Of course, the last one is also, most of the times you may find that the totals are unknown. Sometimes if the totals are not specified, you have to look for the totals to compute those different totals. So those are some of the, of course, the disadvantages of having. So I want us to maybe get one simulation where we are going to require ourselves to draw to use the percentages, but this is going to just be like a personal assessment. So of course, let's have an example 2. Here I want to present the work in percentages. So this frequency distribution shows the number of pounds of each snack snack food eaten during the supper, during the super. So we are saying construct a pie graph for the data. So we have the different snacks. Let's present this information very fast. As of course we have a snack and then pounds. These are our frequency, but they are in millions. So we have the potato chips, we have popcorn, we have the snack nuts. This is 11.2 million pounds. This is 3.8 millions. Then the snack nuts, of course, we have 2.5 million. So let's present these other two snack types, then we get the totals. There's 4.3 million, and then lastly 8.2 millions. We have the total frequency, or what we call the number of pounds. They are 30.0 million, the total. So use that and you construct a pie chart using percentages. And of course I said if they are percentages, you just multiply by 100 instead of multiplying by 360 degrees. So you'll get the frequency of data over the total frequency, then times 100. You get each angle. Now in this one we are getting percentages for each. So we shall meet in the next video as we are looking at the Z chart. Of course, for the Z chart, what we call the Z chart or the Z chart, of course it looks like letter Z, and even when we are drawing it, it will look like that letter Z. So that's what we are going to look at in the next video.